Hello, Mr. Tomswick here again. I'm back for the second part of Lesson 1-4's video. This time we're going to focus in on the notes packet and complete the guided study notes that are in your packet on page 8. So if you would, go ahead and turn to page 8 in your packet and we'll go ahead and get started. Alright, we will begin with our learning target for the lesson. Our learning target is that I can identify parts of an expression. So without further ado, let's go ahead and jump into the notes for this section. So an expression containing variables, numbers, and operation symbols is called an algebraic expression. So an example of an algebraic expression would be 5x plus 3y plus 8. And that can have any number of terms. If you remember back to our vocabulary video, a monomial expression would have one term, a binomial expression would have two terms, a trinomial expression would have three terms, and a polynomial would have four or more terms. The biggest thing that sets expressions apart from something that we're going to talk about in our next unit called equations is that expressions do not have an equal sign. If it has an equal sign, it's not going to be an expression. That changes it to an equation instead. Alright. Each expression is made up of what we call terms. A term can be a positive or negative number. It could also be a variable, or it could be a constant that is multiplied by a variable or more variables than one. For example, you might have 3xy. Each term in an expression is separated by a plus sign or a minus sign. So in the example that we had earlier, 5x plus 3y plus 8, we would say that the terms are 5x, 3y, and 8. Each one of those is a separate term. So going back to that vocabulary we were talking about earlier, this would be a trinomial expression. Now, when a term is made up of a constant multiplied by a variable or variables, we call that constant a coefficient. In the term 5x, our coefficient is going to be 5. Now, a way to remember what a coefficient is, the root word co means depends on. So it depends on that constant having something else attached to it. In this case, we have the 5 and the x connected to each other. They depend on each other. They coexist. So the 5 is our coefficient, as opposed to when you just see a 5 all by itself, it doesn't have anything going along with it. Alright. So, in some terms, the variable will have exponents, such as this term, 8x squared. This exponent is going to be what determines the degree of that term. Alright, so in this case, this particular term would have a degree of 2, and we get that from the exponent right there. Alright, this is a little bit of a lengthy slide, but it matches up with what you have in your notes. So, the degree of 8x squared, like we just said, is 2 because of that exponent right there. Now, since we have an exponent here of 3, what do you think our degree is going to be? If you said 3, congratulations, you were correct. Now, if the variable does not have an exponent, we say that the degree is 1. So that would be a term that looks something like this, 8x. If we don't have an exponent up there, we assume that it's going to be 1, because anything to the first power is what we start off with. That's why we don't write 8x to the first very often, because x to the first is just x, so it saves us time to just write 8x. You'll find as we go through this course that mathematicians can be very lazy, and we like to leave things off as much as we can when it makes sense. So you'll see little things like that pop up as we go throughout the course. Alright, if a term has more than one variable, the degree is equal to the sum of the exponents of all the variables. So for example, and I'll minimize this little bar here so we can see it a little bit clearer, if we have the term 8x cubed y squared z, that is 8 times x cubed times y squared times z. We would have to add up the exponents. Now remember, if there's no exponent, we have an exponent of 1, so that z actually has an exponent of 1. We don't want to forget that. But if we do 3 from the x plus the 2 from the y plus the 1 from the z, that should give us a degree of 6. And if we move our little circle that's covering our answer, we find that we were right. Imagine that. Alright, so if a term does not contain any variables at all, so if it's just a number like 3 or 7 or pi, and it doesn't have any variables at all, we're going to say that the degree is 0. And my little pen's not tracking. There we go. Now we can drag that up and show that the answer is indeed 0. For instance, if we have the term 9, our degree would be 0. And the reason this is the case is that we have x to the 0 power equals 1. So really we could write that, let me get my pen again, as 9x to the 0. But again, just like I said earlier, that mathematicians can be lazy and we like to write as little as we have to and still get by with being correct. X to the 0 is 1 because anything to the 0 power is 1. So this is really saying the same thing as 9 times 1, which the easiest way to write that is just 9. Alright, terms in which the same variable is raised to the same power are called like terms. For example, 8x squared and 10x squared are like terms. To be able to be considered like terms, we have to have the same base, exponent, so in this case they were both x's, and we have to have the same exponent. In this case it was squared. So we couldn't have a situation like where we have y squared and x squared. Those are not going to be like terms because your variable or your base is different. Similar, if we had x cubed and x squared, this time we have bases that are the same, but our exponents are different. We have a 3 and a 2. So these are not like terms. To be like terms, they have to be like our example up here, where they have both the same base and the same exponent. We will call those like terms, and when we get into adding polynomials, we'll look a little bit closer at how we can combine these and use them to our advantage. Now, let's move on to our example problems. Alright, so we want to identify the names for each part of the algebraic expression in 1.8x plus 32. So we're going to start out with our terms. Remember, our terms are individual pieces. So we want to break that up into see what pieces we have. We have a 1.8x and we have a 32. So our two terms are going to be 1.8x and 32. Now our coefficients, remember, are the numbers that multiply the variable. So that is going to be the two numbers that are in front of the variable. In this case, we only have one variable, so we're actually only going to have one coefficient, and that coefficient is going to be 1.8. We don't have a second one because that 32 doesn't have a variable attached to it. It's just a lonely constant number all by itself. So we only go with the number that's multiplying by the variable, in this case 1.8. Now, if we look at the degree, we notice, and I'll erase a little bit so we can see a little bit better, get rid of those highlights and everything. Our degree of 1.8x, so we're looking at the first term again, we should have the degree of whatever the exponent is. Now, you don't see an exponent there. What did we say we could put there? That's right, a 1. So the degree of 1.8x is 1. Now 32 is a constant. It does not have a variable. Remember our rule for that? If it's just a number and has no variable, our degree is going to be 0. Alright, let's look at one more example together and then I'll turn you loose on the practice. Alright, we want to list the terms, coefficients, and degree of each term in the following expression. So the first thing that you guys are asked to do in your notes is to list out the terms. And notice we'll have several terms this time. We're actually going to have 4 different terms, which makes it a polynomial. Our first term is going to be 4x cubed y squared. Our second term is going to be 2x squared. Now be careful on the third term. We want to make sure we include our positive or negative indication. Everything we've been dealing with so far has been plus, but notice this has a minus. So that actually makes our term a negative 3x. And then we're back to positive again, so we can leave that as just 4. It also asks you to list your coefficients. Have to give me a second on my spelling, because spelling is not a strong point. That's why I teach math. There we go. And you have the correct spelling in your notes, so just look at that if you're not sure how I spelled that. Alright, your coefficients are going to be the 4 that you have up here, because it's attached to some variables. It's going to be the 2 here, and it's going to be the negative 3 there. Again, we're going to have to include that negative. So our coefficients again are 4, 2, and negative 3. Now, it also asks you to list the degree of each one. So, the first thing it's going to ask us for is the degree of 4x cubed y squared. Remember, we have to add up all the exponents. So we have an exponent of 3 and an exponent of 2, which is going to yield 5. It wants us to give the degree of 2x squared. This time it's a little bit easier. We just have the one exponent, so we know our answer is 2. It also wants us to give us the degree of 3x. Now, there's no exponent listed. What variable, or what, sorry, exponent is there? It's going to be a 1, so that means we have a degree of 1. And finally, it asks for the degree of the constant 4. Sorry, going ahead and giving you guys the answer. But since there is no variable, like I just tried to spill the secret to, we're going to have a degree of 0. Alright, that wraps up your notes for section 1-4, parts of an expression. Go ahead and begin your practice on page 9 that continues on to page 10. There is no application for this lesson, so once you complete the practice, go ahead and meet with your teacher and get your mastery check scheduled. Alright, see you guys in the next video.